Matting by generation is a novel approach that redefines the traditional regression-based image matting task as a generative modeling challenge. This method harnesses the capabilities of latent diffusion models, enriched with extensive pre-trained knowledge, to regularize the matting process. The proposed method presents architectural innovations that empower the model to produce mats with superior resolution and detail. It can perform both guidance-free and guidance-based image matting, accommodating a variety of additional cues. The main challenge in image matting lies in its ILL posedness, which is a mixed difficulty to find where the foreground is and what the opacity value is in the boundary. Existing methods leverage additional inputs to reduce this ILL posedness, such as capturing another background image or adding priors for alpha through user-annotated trimaps. However, these approaches are not entirely satisfactory, primarily due to their reliance on the segmentation network's accuracy. Recent advancements in end-to-end matting methods have sought to address these limitations by eliminating the need for these additional inputs, thereby reducing the reliance on human-generated data. Nevertheless, developing an effective end-to-end matting algorithm from scratch poses significant challenges due to the task's inherent complexity. The proposed method transforms the traditional regression problem into a conditional generative modeling problem, leveraging a diffusion model enriched with pre-trained knowledge about image semantics and mat details. This approach has several key advantages, including the ability to handle uncertainties inherent in data, mitigate the negative impact of imperfect labels, and offer versatility in accommodating both guidance-free and guidance-based matting. The generative capabilities of the model shine in scenarios where image visibility is limited, and it can perform accurate matting without additional hints. Here is a combined summary of the 2 pages. The authors propose a novel approach to image matting using a diffusion model, which can efficiently process high-resolution inputs and handle various guidance scenarios, including trimaps, masks, texts, and no hints. They review existing matting methods, including guidance-based and guidance-free approaches, and highlight the limitations of conventional trimap-based methods. The authors also discuss the recent success of deep learning-based matting methods and the emergence of diffusion models as a promising approach. The proposed method builds upon the latent diffusion model, LDM, and uses a pre-trained LDM to model the distribution of alpha mats. The authors introduce a generative formulation to model the distribution of alpha mats and use a score-based model to predict the noise introduced to the noisy sample. They also propose a conditional generation approach to condition the generation process on the input image. The authors present a high-resolution, hour, inference method that leverages patch-based inference to address the issue of limited computational resources. They use a predicted low-resolution mat to guide the process and take advantage of the sparsity inherent in alpha mats to reduce computational load. The method involves downsampling the HR image, passing it through the diffusion model, and performing low-resolution inference multiple times using varying random seeds. The authors also discuss the use of text prompts to enhance details in the generated mat and propose a specific text prompt, enhance details. They highlight the importance of adapting the denoising score-based model for alpha mat generation and fine-tune the model using paired data. The proposed method can generate high-quality mats with detailed boundaries and can be used for various applications, including image editing and video production. Key equations and concepts include the generative formulation of the alpha mat distribution, the score-based model, and the patch-based inference method. The authors also discuss the importance of pre-training the LDM on a large dataset of natural images to capture extensive knowledge of image semantics and details. The proposed method for image matting utilizes a generative approach, leveraging a pre-trained diffusion model to refine the alpha mat. The process begins with the calculation of an uncertainty map, which identifies regions requiring refinement. Candidate patches are selected based on high information entropy, and patch-based inference is performed using a noise latent that is not independently sampled. This strategy ensures consistent prediction for different patches, especially in overlapped areas. The guidance mechanism is introduced to address the issue of flawed results due to the model's inability to perceive context information. The predicted low-resolution, LR, mat is used as guidance, starting the backward process from a combination of the upsampled latent corresponding to the predicted LR mat in Gaussian noise. This strategy is effective in extracting low-frequency data from noisy samples. The method can incorporate additional guidance, such as text prompts, coarse masks, and scribbles. Text guidance is achieved through the use of a text-to-image generative diffusion model, while spatial guidance is injected using a similar method to the guidance mechanism. The proposed approach can apply various kinds of guidance directly at inference time without training with them. Experiments are conducted on real-world datasets, including P3M10K, PPM100, and RVP. The results demonstrate the effectiveness of the proposed method in trimap-free matting, achieving the best scores in all metrics. The approach outperforms established methods, particularly in handling intricate details and varying image qualities. Qualitative comparisons showcase the method's ability to capture fine details, such as hair and shoelaces, and produce high-fidelity human boundary mats. The results are more similar to the ground truth, even in cases where quantitative scores are similar. The proposed approach also demonstrates its capability in guidance-based matting, using text prompts and coarse masks to reduce ambiguity. The evaluation metrics include sum of absolute differences, SAD, mean squared error, MSE, mean absolute difference, MAD, and connectivity, CON. The results highlight the robustness and versatility of the proposed method across diverse scenarios, showcasing its advanced ability to generate detailed human boundary mats that are distinct and more aligned with the actual scene. The proposed method for image matting leverages a generative approach, reframing the problem as a diffusion process enriched with pre-trained knowledge for regularization. This approach enables the model to produce high-resolution and high-quality results, as demonstrated by experimental results on 3 benchmark datasets. The method can perform both trimap-free and guidance-based image matting tasks, showcasing its efficacy in quantitative and visual terms. The model's design incorporates a pre-trained generative prior, specifically stable diffusion, SD, which significantly induces semantic information and enables the hallucination of details. Operating within the latent space preserves essential details, crucial for producing high-quality mats with emphasis on boundary regions. This is an advantage over concurrent works built on pixel-based diffusion models. Ablation studies, as shown in Table 3, demonstrate the importance of the pre-trained generative prior, prompting, and multi-scale training strategy. The results indicate that without these components, the model's performance is suboptimal. The use of guidance, as shown in Figure 5, reduces ambiguity and improves matting results. The method's effectiveness is further demonstrated by its ability to produce soft mats for out-of-focus blur, as shown in Figure 10, despite the training dataset not containing annotations for such blur. However, limitations of the method include reduced inference time for high-resolution images compared to naive approaches and potential issues with temporal consistency for videos. Future research directions include enhancing sampling efficiency to mitigate the method's limitations and exploring adaptation to other domains, such as animal matting. The method's design and results have significant implications for the field of image matting, offering a promising solution for high-quality and high-resolution results. The experimental results, as shown in Figures 4 and 7, demonstrate the method's exceptional visual performance, outperforming prior work, including MODNet, P3M, and VITES. The use of HR inference with LR guidance, as shown in Figure 7, highlights the method's ability to produce high-quality results. The randomness test, as shown in Figure 6, indicates that the model's performance improves with the increase of diffusion steps. This research paper presents a comprehensive survey of deep image matting, a fundamental problem in computer vision. The authors provide an extensive review of existing methods, including traditional techniques such as Poisson matting, random walks, and sampling-based approaches. They also discuss recent advances in deep learning-based methods, including diffusion models, transformer-based architectures, and attention-guided hierarchical structure aggregation. The authors highlight the importance of image matting in various applications, including image and video editing, compositing, and augmented reality. They also discuss the challenges associated with image matting, such as handling complex scenes, out-of-focus blur, and varying lighting conditions. The paper presents a novel approach to image matting, which combines the strengths of traditional and deep learning-based methods. The proposed method, called diffusion mat, formulates alpha matting as a sequential refinement learning problem. The authors demonstrate the effectiveness of their approach through extensive experiments on various benchmark datasets, including RVP and Adobe image matting. The results show that diffusion mat outperforms state-of-the-art methods, including MODNet, P3M, and VITES, in terms of accuracy and visual quality. The authors also provide visual results of guidance-free matting on the RVP dataset, demonstrating the ability of their method to handle complex scenes and out-of-focus blur. The paper concludes by discussing the limitations of existing methods and highlighting the potential of diffusion models for image matting. The authors also propose future research directions, including exploring the use of diffusion models for video matting and developing more efficient and effective methods for image matting. The paper provides a comprehensive review of the literature, including over 50 references to existing methods and techniques. The authors also provide detailed explanations of the mathematical concepts and algorithms used in their approach, making the paper accessible to researchers and practitioners in the field. Overall, this paper presents a significant contribution to the field of image matting, providing a novel approach that combines the strengths of traditional and deep learning-based methods. The results demonstrate the effectiveness of the proposed method, and the paper provides a comprehensive review of the literature and future research directions. Matting by Generation, a research paper presented at the SIGGRAPH Conference Papers, 24, introduces an innovative approach to image matting. The authors compare their method with existing techniques such as DiffMat, Xu et al. 2023a, MAM, Li et al. 2023a, and VITES, Ma et al. 2023. In Figure 11, the authors showcase trimap-based matting results. Although their visual results appear better than those of DiffMat, their evaluation score is slightly worse due to imperfect human annotation. This discrepancy highlights the challenges in accurately assessing the performance of matting algorithms. Beyond portraits, the authors demonstrate the effectiveness of their approach in Figure 12. They compare their results with MAM and VITES for a giraffe image. MAM can generate a semantically correct alpha mat but loses some detail, while VITES fails to produce a semantically correct result and also loses details. The author's method closely matches the human annotation, indicating its potential for accurate matting in various contexts. The paper emphasizes the importance of developing robust and versatile matting algorithms that can handle diverse images and scenarios. It also underscores the need for more accurate evaluation metrics to objectively assess the performance of these algorithms. Overall, this research contributes to advancing the field of image matting by proposing a novel approach and discussing its merits and limitations compared to existing methods.